This video will take you through building a row matrix for a specific 12-tone row from the Webern piece on the screen right now. This is from assignment 38.5 in your workbook on page 491. This is part A. So the instructions here are to make a row matrix for the 12-tone row that's given. On page 492, you're given a grid, so we'll be using that grid in a minute. If you want to make sure that you have your workbook out on page 491, that would be a good idea so that you can do this with me. You are assigned this week part B, so this is just a demonstration of how to do that portion of the assignment. So we have a Webern melody. Our first step is to begin by writing the pitch classes below the staff. So here on the page we see the letters PCS, that stands for pitch class. We are going to write the pitch classes representing the pitches in the melody. So first we see F, that's a 5, G, 7. I'll go through these. E is 4, E flat is 3. And so on. I'll just fill these in while you listen and watch. I'm on the C, which is 0 in measure 5. A natural is 9. C sharp is 1. And then my G sharp last note is 8. So all I've done is write the integers pertaining to the pitches in the melody in the row. My next step is to transpose the row so that it begins with 0. So when I do this, I am either subtracting 5 to get from 5 to 0, or I can add 7 to everything, depending on which way gives me the number that I want to deal with, I guess. So subtracting 5 would work in this case. My next number is 7. 7 minus 5 is 2. 4 is next. So here, so they're either going to subtract 5 or add 7. With the 4, I'm going to choose to add 7 to this because that's going to give me 11. 3, same thing. I'm going to add 7 so that I get 10. 11 is next. I'll subtract 5 from that so I get 6. 2 plus 7 is 9. 10 minus 5 is 5. 6 minus 5 is 1. 0 plus 7 would give me a better answer than 0 minus 5. I have to deal with negative numbers. So 0 plus 7 is 7. 9 minus 5 would give me 4. 1 plus 7 is 8. And 8 minus 5 is 3. So all I did here was transpose my row so that it began on 0. How do I get from 5 to 0? Well, I can subtract 5 or I can add 7. So that's how I should transpose my row. Now my next step is to write the P0 row form, which I just wrote out, on the matrix. So my next screen here, I've already done that. 0, 2, E, T, 6, 9, 5, 1, 7, 4, 8, 3. So I wrote that P0 line across the top row of my matrix. My next step is to complete the inversion, I0, going down the column. Now, to do this, I'm using a little bit of a trick. I can figure out how do I go from the first member of my row to the next. In P0, I'm adding 2. So in my inversion, I'm going to subtract 2. I can continue on like that. If I'm looking at 0 to 11, 0 to 11, I'm subtracting 1. So 0 to my next square down, I'm adding 1. I can do that. Another way I can do this is to make sure that each of the corresponding pairs add up to 12. So I'll put in these colors for a moment so you can see this. Okay, we'll do that much with the highlights. So my second member of my inverted row would be T, because when I have 2, I need to add 10 to it to get to 12. So I want these sums to equal 12. 11 and 1 equals 12. 10 would be my next member of my P0 row. 10 plus 2 is going to give me 12. Next member 6, 6 plus 6 will give me 12. So I'm just inverting the row. I'm inverting using the clock face. What's the inversion of a 9? It's 3. What's the inversion of 5? 7. 1 inverted is 11. 7 inverts to 5. 4 inverts to 8. 8 inverts to 4. And 3 inverts to 9. Next, I need to complete the rest of my matrix. So I can do this in a couple of different ways. I can either just go down the column, the inverted column, and transpose each P0 row to that starting point, or I can go in order. So I prefer to go in order, where I find P1 next. P1, do some erasing here. P1 is right there where my black arrow is. And I'm just simply going to transpose P0 so that it is P1. 0 plus 1 is 1, 2 plus 1 is 3, 11 plus 1 is 0, 10 turns into 11, 6 turns into 7, 9 turns into 10, 5 into 6, 1 plus 1 is 2, 7 plus 1 is 8, 4 plus 1 is 5, 8 plus 1 is 9, and 3 plus 1 is 4. Next, I'm going to find row 2, which conveniently is the next row down. Right. So again, I'm going to take all the members of P1 and add 1 to everything. So 1 turns into 2, 3 turns into 4, 0 turns into 1, and so on down the row. I'll complete the next row, find 3, and add 1 to everything in the row 2. So now I'm here. 3, 5, 2, 0 plus 1 is 1, 0, 7 plus 1 is 8. I'm simply going through. Next, I'm going to find row 4 and add 1 to everything in row 3. Sometimes it helps just to isolate the row if you can. Do that. I'm adding 1 to everything in row 3 to get to 4. So this is just a transposition. And then I'm going to find 5, add everything to row 4, and place it in row 5. Finding 6, take everything in row 5, add it to 6. Sorry, everything in row 5, add 1 to get to row 6. 7, 0 plus 1 is 1, 9 plus 1 is 10. From 6 I find 7, again add 1 to everything in row 6 to get to 7. 7 to 8, add 1 to everything in row 7. 8 to 9, add 1 to everything in row 8. Again, I'm going to use that top of my screen here to help. Row 9, I got to look all the way up to row 10. I could also, if I wanted to, subtract 2 from P0. That would work as well. And then 11. So find my P10 and add 1 to everything to get to 11. With any luck, I see that my diagonal is all, all zeros, and it's not, but this is an easy mistake to fix. As I compare the last number of row 10 here to row 9, and I should have just subtracted 1, so that is an easy mistake to fix. And everything should work out. Now going back to my assignment page, my workbook page 491, they're asking me to use the matrix and write out the following row forms. So the first one they want is I5. That's going to be the inversion row that begins with 5. So right there. And that row is 5, 3, 6, 7. E80 4T192. So I would just write that in. The next one they want us to find is RE. RE is a retrograde row, so I'm going to look on this far column, the right-hand column, but it's going to be the reverse of PE. So I find PE. Erase some of these arrows, get out of our way. PE is there, and RE would be the reverse of that. So retrograde row forms are always labeled with the first integer in the P form that it's the retrograde of. So this is PE, but it's retrograde. So it's retrograde of PE. We just take that P out. So I would just write those integers in this space in the workbook. I'm not going to do that now. Next one is P7. I find a row form, prime form that begins with 7. There's P7. And then I want RI6. So again, I'm finding the inversion, I6, and then the retrograde of that is RI6. Now we can use this matrix to analyze a little bit of our piece. So we'll do that in the next video.